Hello, everyone. This is Elisa Baum, the Percona's Director of Product Marketing. We'll begin in just a minute, but I'd like to conduct the typical housekeeping I do when we do these webinars. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me okay? So if you could please raise your hand. Let's see, are there any hands? Oh, thank you very much. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL performance blog. In addition, a recording of this webinar will be made available to everybody within 48 hours. I would like to thank you for attending today's webinar, MongoDB 101 for MySQL DBAs and developers, and it's being presented by Percona architect Stefan Combondon. And with that, I will turn the floor over to Stefan. Go ahead.
Thank you, Alisa. So welcome to everybody for this to this webinar. The topic of today is MongoDB, and maybe the first thing to mention is that I won't talk a lot about MongoDB 3.0, and the main reason is that as it's a brand new release, I don't have production experience on MongoDB 3.0, so I won't really be able to tell you more than what you could find on the internet. So as there are many things to say about MongoDB, well, I prefer not to talk about MongoDB 3.0. Okay, so that being said, here is the agenda for the session. The first part will be a quick, not that quick. So an introduction to MongoDB. So you're using MySQL. Why should you use MongoDB, or why could you use MongoDB? Then we'll see some basic operation like, okay, how can you select data from MongoDB, insert data from MongoDB? We'll talk about schema design, because you probably know that MongoDB is non-relational and schemaless. So what does it mean when you want to model your data for your application? We'll have a short talk about the aggregation framework, which is a framework to run aggregation queries, that is, reporting queries. And then we'll finish by talking about replication, so high availability, and sharding for scaling. So let's get started. The first part is why MongoDB. So if we go back to 2007, 2008, when you use MySQL, there were a few issues that were very typical but very annoying. So the first one is, and it's still true today, it is that the SQL language is quite difficult to read and write. So actually, it's quite easy to write a SQL query, but to write a SQL query that does exactly what it should do and to write it efficiently, that's not easy. So many people complain that SQL is difficult. Second complaint is that schema changes can be really hard as long as you have large tables. And the reason is that in MySQL, when you run alter table, you log the table. So you can't write. And if the table is large and if the alter table takes 3 hours, that may be difficult to run. So the issue is that for modern applications, you will require flexibility. That means that the code will change, the requirements will change, so the database schema must change, and that should be smooth. Okay. Third very typical issue is about high availability and scalability. So, for instance, 5-6 years ago, with in the MySQL ecosystem, it was quite difficult to find a good HA solution. So you had a few options, but they all had trade-offs. It was quite difficult. And well, when we talk about scalability, one of the first thoughts is thinking about sharding. And sharding in MySQL is difficult because there's basically no support. So if you want to shard in MySQL, you can do that. It's all manual. So not very nice. Now let's see what MongoDB can offer. So first, SQL is difficult. Okay, with MongoDB, you don't have SQL. You have a new developer-friendly language that you can use. So instead of writing select star from people where name equals Joe, for instance, you have another syntax that you may or not find friendly, but at least the goal is that most developers will find that this is easy to use. And the funny thing is that in the SQL world, DBAs understand the SQL language. For developers, it's a bit more difficult. Now with MongoDB, well, developers understand the queries very well, but for DBAs, it's a bit more complex. Now, regarding the problems with schema changes. Well, for MongoDB, it's very easily fixed because you have a schemaless design, which means that you can change the schema without running alter table. So this is very easy, nothing to do. This is built in, great. However, well, being schemaless is not so easy and flexible and magical. We'll talk about that later. Third thing, high availability and scalability. Well, in MongoDB, it's very simple. For high availability, you have one feature, which is replication with replica sets. It's asynchronous replication. You have automatic failover. So if the master fails, another member of the replica set is promoted to be the new master. It works quite well. And anyway, that's the only solution. So you don't have to think a lot about what to implement as an HA solution with MongoDB. Now, regarding sharding, it's very cool with MongoDB because you have automatic and transparent sharding. So sharding is done at the table level, and the data is automatically spread over all the shards and rebalanced if needed in the background. And you also have an extra binary, the MongoS, which is a query router. And with MongoS, sharding is completely transparent to the application. So when the application runs a query, it doesn't need to know that the collections, the underlying collections or the underlying tables are sharded. MongoS will redirect or will ask the correct shards for you. So that's great. So, well, this is impressive. Lots of great lots of features that will simplify your life, simplify development, simplify administration. So, well, you should use it. Is that true? Well, there are some other things, some other aspects to consider. So the first thing is that MongoDB is still a young product. So it was first developed, I think, in 2007, 2008. So this is 6-7 years. We still have many bugs. Many bugs are fixed with each version, but still, we have many bugs. Single node performance is not great. So it's interesting to see that sharding is very easy with MongoDB, and it's very fortunate because you need sharding very quickly in the life cycle of your application. So, well, having not good single node performance is sometimes annoying, right? Schemaless, well, this is a good feature. However, it brings a lot of new issues that you will never find in the relational world. So is it good, is it bad? Well, it depends, but at least it's good to know that it's not all good. And another thing is that MongoDB was first developed because of drawbacks of the relational databases and MySQL specifically. Well, MySQL has improved a lot since 2007, 2008. So, for instance, complex queries are executing much more efficiently in 5.6. For HA, now you have very good options. You have Galera with synchronous replication. You have the new GTIDs, the global transaction IDs. You have MHA, which works with asynchronous replication. So Well, HA is, I won't say that HA is no longer an issue with MySQL, but at least you have good solutions for that. And MySQL has now improved a lot on performance on a single node. So you can use powerful hardware with MySQL. And that means that scaling up, so scaling the hardware, is a good option when you need more performance. And it can be preferred to sharding. So, well, with MySQL, you may still need sharding, but probably not as quickly as you will need it in MongoDB. Okay, so let's jump to the second part. So see how we can inject data inside into MongoDB and then get the data back. So before we talk about insert or select, let's talk about a bit about terminology. So comparing MongoDB and MySQL. So in MongoDB, you have a few binaries. So the first one is MongoD, that's the server. So it's the equivalent of MySQL in the MySQL world. You have Mongo, which is the command line client, equivalent to the MySQL command line client. You also have MongoS, which is the query router for the Sharding clusters. You don't have an equivalent in the MySQL world, right? Then in MongoDB, it's a database, so you have data, and data will exist in databases. So a database in MongoDB is exactly the same thing as a database in MySQL. Then you have a collection. So a collection is a table in the MySQL world. And then inside tables, so inside collections, you have documents. In MySQL, inside tables, you have rows or records. Okay, JSON. So I guess most of you know what JSON is. So it's a lightweight alternative to XML. It's very important in MongoDB because all the documents are JSON documents, and internally they are stored as BSON, which is binary JSON. So one good thing with JSON is that it's a format that is really easy to work with for developers. So this is one of the reasons why developers love MongoDB, because it speaks JSON natively, which is not the case of MySQL. Now, MongoDB is document-oriented database, so all records, let's say records, are actually documents. So what is a MongoDB document? It's simply a set of key-value pairs. And the value can be a lot of things. So in the example that you have on this slide, you have the first key, which is name, and then the value is a string. Then you can also have an integer, but you can have more complex types like an array, or you can also have another JSON document, right? So you can have nested JSON documents. Another important thing is underscore ID. So underscore ID is the unique identifier of any document. So it's pretty much like the primary key in the relational world. And you can either set it explicitly. So when you insert some data, you can set underscore ID equals something. Or if you don't do that, MongoDB will automatically create a special type of ID, which is called object ID. And object ID is roughly similar to an auto-incremented integer in the MySQL world, right? And anyway, so as underscore ID is the unique identifier of a document, you will always find this field in any document. Okay, so now let's see how to insert some data. So let's say that we want to insert a document. So the document will be a document with two fields, name and age, and we want to insert that document inside a people table that is in the test database. So if we use the Mongo client, the command line client, we will simply run use test, like in MySQL, and then db.people.insert, and then we specify the JSON document. So one interesting thing is that we don't have to specify a create database. So we typed use test, and if the database doesn't exist, that's not an issue. It will be created for you. Then we run db.people.insert. If the people table, so the people collection, doesn't exist, it's not an issue. MongoDB will create that for you. So MongoDB is, well, let's say, nice with you. It will create the missing objects for you. Now that you know how to insert some data into the database, let's see how to fetch data. So for that, you have another operator, which is find. So if we want, for instance, to find all the documents in the people collection where the name attribute is Joe, we will run db.people.find, and then so the JSON document with name : Joe. Very easy. So the equivalent in the MySQL world would be select star from people where name equals Joe. You have one small variation, which is to use the find one operator instead of the find operator. It will only return one document. So that's the equivalent of in the SQL world of doing the same select but with limit 1. Okay. So of course you have a lot of options for the find operators to write quite complex where conditions. Of course you can use inequalities, you can use you can filter on several criteria with and or. You can use regular expressions, you can use conditions on subdocuments, conditions on arrays. Okay, so you have lots of options. You can also use the update operator to update one or several documents. You can also delete, use the delete operator to remove documents. You have a count operator, a sort operator, a limit operator. So you have lots of different functions that are available. So as we don't have a lot of time, I won't spend time explaining all the details about all the operators. You can simply look at the documentation, the online documentation. Everything is very well explained. In MongoDB, you also have indexes. So they are supported and they work pretty much the same way as they work with MySQL. So if you know what you can do with indexes in MySQL, you will find that in MongoDB it's mostly the same thing. So you can use an index to filter efficiently, or more efficiently than without an index. You can use an index to sort efficiently, and you can also have covering indexes, which means that you have an index that will allow you to solve a query without reading data. All the information is in the index. You have a few nice things that you have with indexes in MongoDB that you won't find in MySQL. For instance, you can specify if the index is created in ascending order or descending order. So this is nice. You can also have when you have replication, you can have background creation of the indexes, which is also something that could be nice. Okay, great. So next topic is schema design. So basically, we will consider two aspects of MongoDB. The first thing is that it's schemaless, and the second aspect is that it is non-relational. So the first thing is, okay, MongoDB is schemaless. What does it mean? Okay, let's take a simple example. We will insert a document. So this is a very simple document, only one field, name. And so we have a value. Now, so we have an application that will use this collection, so with the data with a single field, and we want to change our app to add a new field. So how do we add a new field in the database? Well, for new document, that's very easy. We use the insert operator, and we simply specify a document with two fields instead of one, and that works. That will insert a new document with two fields, and it doesn't matter that the other documents in the collection only have one field. It works. So MongoDB is very flexible. All the documents don't need to have exactly the same number of fields. So no alter table. And now, if you want to update an existing document, that's also very easy. You call the update operator, and you specify the new field. And well, that's all. Again, no alter table or alter collection. That works. It's very easy. Okay, so that's all good. However, do we have any drawback of this schemaless design? Well, actually, yes. The first thing is that the database will never enforce the schema. And all these kind of checks are deferred to the application. And if the application doesn't do that, so it doesn't do the checks, well, you can do stupid things without, without realizing it. So, for instance, we have an example of something that can happen in MongoDB and something that will never happen in the relational world. So we insert a first document with two fields. The first one is name, and the second one is country. And then some other part of the code will insert another document in the same collection, and with again two fields that are supposed to be the same. Unfortunately, the first one is still name. However, the second one is location. And for MongoDB, that's not an issue because, of course, MongoDB doesn't check anything. So the issue now is that for the application, you have the same field, but it doesn't have the same name. So the name of the field is not consistent across all the documents. So yeah, that's quite problematic to solve. So you must make sure that the application is consistent in the way it inserts data. So of course that will never happen in MySQL or relational databases because the schema is fixed. So if you say you create a table and with two fields, the first one is name, the second one is country, well, then the second insert, it will fail. So we'll immediately see the problem. So that's one of the drawbacks of being schemaless. The second drawback of being schemaless is that the attribute names are no longer metadata. They are part of the data. Why can it be significant? Well, simply because if you have large collections, so let's say you have 1 million records, and that means that the field names like name, country, location, address, etc., they will be stored 1 million times. It's not very efficient. That eats some space. So, and it also means that if you have two documents with, let's say, the same content, but one with short field names and one with very long field names, the size on disk will be different, which is which is quite counterintuitive. Let's say that. So think about that. Now, the second aspect of schema design is MongoDB is non-relational. So what does it mean non-relational? So basically, non-relational means, well, we don't have joins. We don't have relations. Let's say we don't have joins. And so data will be denormalized, right? So what will happen when you have relations? Like you can have one-to-one relations or one-to-many or many-to-many relations. Well, for one-to-one, relations and some one-to-many relations, what you can use is a technique called embedding. And embedding simply means, well, instead of having two separate collections and then using a join to get results from both collections, you will include one collection inside the other collection. So here is an example. Let's say we have posts and comments. So in the SQL world, we would have a post table and a comment table. And if we want to know all the comments from a user, we would write a join. With MongoDB, we don't have any join, so we have to think differently. So what we can do is for a given post, we can embed all the comments inside the post document. So here we have a post underscore ID equals something, the title, and then we have a list of comments. So the comments field is an array, and it's an array of JSON documents. And well, this is fine, because if you want to find all the comments for a given post, that's very easy. You simply fetch the post by ID, and you have all the comments. That's great. However, well, again, we have a few. There are a few drawbacks. So the first one is that a MongoDB document is limited to 16 megabytes. So, well, 16 megabytes, that looks like a lot. However, that can be very quickly reached if you have one-to-many relations where many is very large. So be aware of that. For some relations, you won't be able to use embedding. It doesn't work with many-to-many relations, because then what you would need to do is to embed collection 1 inside collection 2 and collection 2 inside collection 1. Well, it doesn't work well. And maybe the most significant drawback is that not all data access patterns are equal. So if we go back to the previous example, let's say that we want to find all the comments for a given post. That's the example I gave, and that's very easy. We simply fetch the post by ID, and we have the comments that are embedded. Very good. Now let's say that we need to change our app, and we also want to display the total number of comments. Well, that's hard, because we don't have a comments collection. So if we want to know the total number of comments, what we have to do is to parse the whole post collection, and for each post we have to count the number of comments and then sum it all over the collection. That's not good at all. So it's very important to remember that when you have to do schema design in MongoDB, you have to think about your data access first. If you don't do that, you may create a data model that is not good for your queries. Okay. So how flexible is MongoDB regarding schema design? Well, basically, because it's schemaless, it's very flexible when it comes to structuring the data inside a collection. You can do basically whatever you want, and it's also great to have let's say complex data types like arrays or subdocuments. That adds a lot of flexibility. However, the non-relational aspect of MongoDB implies that each time you will have to work with relation, you'll have a hard time, because, well, again, you must know your access patterns before modeling your data. And the question is, okay, but what if your access patterns change? So we talked in the introduction. I mentioned in the introduction that one of the goals of MongoDB was to be flexible regarding the schema. Well, that's true because it is schemaless, but that's not true because it's non-relational. So you have to think beforehand of a schema, and when it's done, well, if you want to query your data in a different way, it doesn't work. That's not that good. And of course, in the relational world, this problem won't happen because normalized data is, let's say, uh, access agnostic. So you can access the data in many different ways, and it will work well or quite well all the time. So that's a different way, at least, to think about MongoDB. Okay. Let's quickly review the aggregation framework. So as I mentioned in the introduction, the aggregation framework is meant to run reporting queries. So queries with group by, sum, count, average, etc. In MongoDB, you have two options: aggregation framework or map reduce. In general, the aggregation framework is better because it's easier to use and faster. But for some complex queries, you will need the map reduce. I won't cover the map reduce here. So here you have a simple example. So, well, if you look at this example, you may think, that's not easy at all because the syntax is, wow, it's so complex. But actually, if you look at the MySQL equivalent that is at the bottom of the slide, it is still quite simple. So what we are doing here is that we want to select all the different names that we can find in the people collection. So all the names greater than m, and then for each name we want to know the number of people we have. So actually that's a pretty simple query. So let's look at how the aggregation framework works. The idea is that we have documents as an input, and then the documents will be modified through pipelines like Unix pipelines. So in the Unix world, for instance, let's say you have the /etc/password file. You can use grep to filter. Then you can pipe it to sort, and then you have another, let's say, file, and then you can use awk on that output to do something else. And in the end, you have an output. Well, with the aggregation framework, it's exactly the same thing. So if we go back to our query, what we want to do is to do some aggregation query on the people collection. And the first step will be to use the $match operator, which means we'll filter some documents. And when it's done, we will use the $group operator to group documents by a given criteria. Okay. And then you have the details. So $match, we specify the filtering condition, and then in the $group with the $group operator, we specify which is the grouping with which field we want to group, and then we also specify if we want to do sum and average, everything, things like that. Okay, I don't want to spend too much time on the aggregation framework because replication and sharding are the next two topics, and they're very interesting. So let's talk about replication first. A very brief overview of replication in MongoDB. It's asynchronous, which means that all writes will go to a single server, which is the master. We have secondaries. The secondaries can accept reads, but by default they don't, which is surprising when you come from MySQL. If the master fails, you have a new master that will be automatically elected, and in some situation it can be useful to set up an arbiter, which doesn't hold any data, but that can be here to help in the election process. If you have ties. So here is a schema. So with a replica set containing 3 members, so you have the primary, you write on the primary, then the writes are replicating to the secondaries. And what you can see is that unlike in MySQL replication, you have some group communication. So all the nodes communicate with each other from time to time to check that every member is available. So now how failover works. You have heartbeats that are sent every 2 seconds from each server. And if one heartbeat is not replied within 10 seconds, then the node is marked as a down node. So if the master doesn't reply, so after 10 seconds, if it doesn't reply to a heartbeat, the over nodes will start electing a new master. Basically, and by default, so if you, let's say you have a 3-member replica set, the master fails, any of the 2 remaining members can be chosen as the new master. But what you can do is to set a priority to one of the nodes to influence the result. So for instance, if you have 2 secondaries and you say that priority for the secondary number 1 is 10 and priority for the secondary number 2 is 5, the secondary number 2 will always be chosen as the new master. So this can be useful, for instance, if you have 2 servers in one DC and 1 server in a DR DC. So you can make sure that whenever it's available, the secondary in the main DC will be chosen as the new master. You can also have members with priority 0 or hidden members that cannot be promoted, so they can act as regular servers to serve read queries, but they won't be promoted. And arbiters will never be promoted, mainly because they don't have any data. An interesting thing that doesn't exist in the MySQL world is the write concern. So write concern is basically, well, let's see how durable you want your writes to be. So it's a setting that is, it's what is called the W parameter, and it specifies how many nodes should acknowledge a write. So by default, W, so the write concern is 1, which means the primary only should acknowledge the write. You can also set it to 2, which means that the primary should acknowledge the write and any secondary should also do that. More interesting is W equals majority, which means that the majority of the nodes should acknowledge the write. So if you have 2 nodes, as long as if you have 3 members, as long as 2 members have acknowledged the write, the writes will return, and well, that's interesting for data safety. You also have, I think, W equals all, which means that you need to all the nodes, all the members should acknowledge the writes. Of course, the issue can be that, well, it may be very slow. But in general, if you have a high W, it means that your data is safer because it will you are guaranteed that the data is stored on different servers, but it's also slower, of course. Another interesting thing is the read preference, which is basically where can you read from. So by default, it's primary, which means that you can only read from the primary. But you can also use primary preferred, which means that in general, the primary will be preferred, but in some circumstances, the reads will be served by a secondary. You can also specify secondary preferred, or nearest. Nearest means in terms of nearest in terms of a network latency. Another thing that you can do is to use custom tags. So that can be used both for write concerns and read preferences. So what is a custom tags? So basically what you can do is to add specific tags for any member of the replica set, like, well, location equals US, disks, SSD, war reporting, CPU, high, anything you want. And the idea here is that you can use such custom tags for either the write concerns or the read preferences, and that can be very useful when you want the reads or the writes to run on a given server or a given set of servers. So, like for instance, if you want to make sure that a write, so let's say you have 2 data centers, if you want to make sure that a write is written on the secondary data center, on the secondary data center, you can use write concerns. It can be more efficient than using something like W equals majority, because sometimes W equals majority will not enforce that the write is acknowledged on the secondary side. With write concern, it can be easier. Okay, so let's move to the last part, which is sharding. The first thing to know about sharding is, of course, when you need to shard. Basically, you have three conditions, and you should shard whenever you hit one of them. So the first condition is when the write capacity exceeds the capacity of a single node. Well, so basically, if you want to write, let's say 10,000, so if you want to run 10,000 writes per second, but your server can only deal with 9,000, well, of course, there is no issue with that on a single server, so you need to shard. Second option is when the dataset no longer fits in a single server. So that could be the case. Let's say you have 4 terabytes of data. Well, you can still have local disks, but they will be slow, or you can use a SAN, but that's very expensive. So it can be useful to simply shard the data and have a smaller data set on each shard, and then be able to use fast local disks. That can be useful. And the third condition is when the working set no longer fits in memory. And that's quite interesting, because in the MySQL world, the first two conditions are also good conditions for sharding, but not the third one. So it's interesting to know that in MongoDB, to keep performance good, you need a working set to fit in memory. As long as it doesn't fit in memory, well, performance will degrade very, very quickly. So now, what are the components of a sharded cluster? Mainly, you need three parts. The first thing is, well, the shards, or the data servers. So what you will use in general is a replica set for each shard, because you want to provide high availability. So in a testing environment, you can use a single server for a shard. In production, well, you will never do that. So you have a replica set with at least 3 nodes, 3 members. Then you have the config servers. The config servers are simply MongoDB instances that will store the metadata. So there are MongoDB instances started with some specific settings, and they will only store the metadata, nothing about the data. And then you have MongoS, so one or several MongoS instances. So they will be used by the application to, let's say, route the query to the right shards, so that the application doesn't need to know about sharding. And the MongoS instances will cache data from the config server. So the config server have the information about how sharding is configured, and to avoid that, MongoS instance needs to run a query to a config server each time it runs a query it needs to run a query. This is cached. And here we have a diagram trying to recap everything. So the big part is the shards, which are all replica sets. On the left, you have the config servers. So in production, you should have 3 config servers to make sure that they are also always available. So the config servers, they're using a special two-phase commit protocol to acknowledge the write, so that there's no conflict, etc. So it's quite slow. However, the write workload is very limited, because the only things that are stored, or the only traffic that will flow through the config servers, is the changes in the sharding configuration. So that doesn't happen very often. And then at the bottom, you have your application and MongoS. So MongoS can be deployed, well, anywhere, but you can deploy it locally on your web server, for instance. And so instead of querying the replica sets directly, the application will send the query to MongoS, and then MongoS will do the magic and ask the right shards to get the data. And if several shards need to be asked for data, MongoS will merge the data before sending it back to the application. So that's very convenient to use. So sharding is very convenient to use at the application level. A few features of sharding. First, it's automatic, which means that what you specify is simply which collections should be sharded. And then for each sharded collection, you also specify the sharding key. And then in the background, MongoDB will split the data in chunks. And then it will spread all the chunks over all the shards. And of course, once this is done, your system will see, right, so data will be inserted, updated, deleted. So even if the initial, even if the chunks are initially balanced, so spread evenly across all the shards, that may not be true after some time. So what MongoDB does in the background is that it can trigger a rebalancing of the data if the data becomes non-evenly distributed. So that's quite interesting. So and the thing to know is that if you have a large collection and you decide to shard it, sharding will take some time to be effective, because again, splitting the data is done in the background, and MongoDB takes some precautions to make sure that it is not too impacting at the application level. So if you have a very large collection, it may take a few hours or maybe even a few days before the chunks are correctly balanced across all the shards. And then the second thing is that sharding is transparent. So the application doesn't need to know about sharding. The application simply needs to connect to MongoS, and that's all. And each time there's a change in the configuration of the sharding, so for instance, when some data chunks are rebalanced, so are moved from server 1 to server, so from shard 1 to shard number 3, that means that the config servers will be updated. But again, the end user has nothing to do, because when that is done, the config servers are updated, and then the config changes are pushed to MongoS. So MongoS always know where to find the data. So this is pretty cool. So this is time for the question. So thank you for attending, and now back to you, Alisa.
Hi there, can you hear me okay? Stefan?
Yes, we can. Yeah.
Okay, great. Before we get to the questions and answers, I just wanted to point out that the MySQL conference, Percona Live, is coming up quickly, April 13th through 16th in Santa Clara, California. And I have a special discount code for you if you have not registered. For any attendees on this webinar, use the code WebinarPL, and you can get 20% off any new ticket, any ticket type. And the link to the conference is shown here. All right, with that said, let me get into the questions for you. The first question is, for what application would I use MongoDB over, say, MariaDB with Galera, Spider, etc.?
Yeah. So one case I've met a few times is applications where you have, let's say, you have a table, and in this table you have lots of optional fields. And the problem of that kind of design in MySQL is that you can easily end up with a table with, let's say, 100 fields, and for most of the records, only 10 or 15 fields will be filled. So you take a record, and basically every field is null. So null, 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 null. that's not very efficient. So you end up with a very large table, which basically only contains, well, null. That's not great. So with MongoDB, this design is much easier because you will only store the attributes that you will use. And again, if you need to add a new attribute, that's very easy because even if your table is very large, even if your collection is very large, you don't have to run an alter table. So you need a new attribute? Well, but simply use insert, so the insert operator with the new attribute, and MongoDB will be okay. So this is one specific case where MongoDB would make a lot of sense. Another situation is, and it also happens quite frequently, MongoDB speaks JSON, as I mentioned, and it speaks JSON natively. And for developers, JSON is a great format because it's easy to work with, it's very flexible. So, and with many languages, you can write very small scripts or very small programs that can process the data efficiently. So if you have your database that can understand JSON, you don't have to, get the data from the DB, transform it to JSON, do the things in the application, and then transform it back to the format the database expects. So the process of developing the application is much more, it's much smoother.
All right, the next question is more of a comment, and it is Mongo recommends all read writes go to primaries. Mongo does not recommend trying to scale by reading from secondaries. The secondary nodes are only supposed to be used for HA, not scaling. Do you have any comments to that?
So yeah, that's right. That's right. That's the official recommendation of MongoDB. Well, however, in some situation, it is useful to read from the secondaries, and the reason is basically that it can easily become very expensive to only use the primaries. So let's say you shard, so you have 10 shards. Each shard is a 3-member replica set, so that's 30 servers. And out of these 30 servers, well, you're basically only using 10 of them. So, well, okay, replica set is a great feature to provide high availability, but it could be very useful in some cases to be able to use the secondaries. So, and I think that another reason why MongoDB doesn't recommend to use the secondaries is that as replication is asynchronous, replication can be lagging on the secondaries. And of course, if you're familiar to the MySQL world, you're familiar to slave lagging behind the master and all the issues that you have, like you write something on the master, you read the data you just wrote on the slave hasn't the data, so it doesn't work. And well, by reading and writing on the primary, of course, you don't have this this problem. So well, that the recommendation, of course, of MongoDB, of course, makes sense, but we have seen in some cases that people use secondaries for reads.
Okay, great. Thank you for answering. This might be a somewhat redundant question, but I think I'm going to ask it again because several people have asked it. When is it better to use Mongo and when MySQL? Or is the best solution using a combination of MongoDB and MySQL?
That's a very good question, but unfortunately that's very hard to answer. So from what I see quite frequently, I'd say that it can be very useful to use both tools, simply because MySQL is very well suited for many kinds of workloads, many kinds of applications, but sometimes you have, well, let's say a few corner cases in the application or a few tables where MongoDB, MySQL is really poor choice because you have to do either a poor table design or poor queries. And you would benefit a lot from having a schemaless design. So in that case, it could make sense to have some part of the application using MySQL and some part of the application using MongoDB. Of course, that's not always easy because if you have a system that constantly need to fetch data from either MySQL or MongoDB, that's a lot of complication. Um, Typically, systems that could be that could benefit from MongoDB are systems that are using MySQL or any relational any relational database, but with schema like EAV, so entity attribute value, which is a way to have a flexible schema in the relational world. However, the price for this flexibility is very poor performance. And if you chose MongoDB in that case, that could be much better because you would use, let's say, standard MongoDB with all the good things, while you're using non-standard MySQL with EAV. So, well, that's some of the situations where you could use MongoDB over MySQL, or both using both could be relevant.
Okay, I think we have time for 2 more questions or so. So the next one is, what is MongoDB best suited for, OLTP or DSS, as in data warehouse?
Again, it's quite difficult to answer. So, like MySQL, MongoDB can do both. You have the insert, update, find operators, so that you can do OLTP. You also have MapReduce, or the aggregation framework, to do reporting queries. So you can do everything. You can scale pretty easily with sharding. So you can have a lot of traffic and still have good performance. I say that one of the differences is that with MongoDB you should be prepared to shard very quickly, because as I mentioned at the beginning of the slides, single node performance is not great. It should improve in MongoDB 3.0. So in the versions before, one of the reasons why single node performance was not great was because of locking. So the storage engine used by MongoDB is pretty much like my ISAM in MySQL, and we all know that my ISAM doesn't scale well. So as long as you don't have lots of concurrency, as long as you don't have lots of writes, it can work well. But in general, it's not a good choice. And for MongoDB, well, that's the same. The mmap engine is not good. So if you want to use MongoDB, you will need to shard. So with sharding, you can have very good performance. However, that means that you will need to run with maybe 30 servers, 30 small servers, while with MySQL, you would only need maybe 3-5 servers. So again, yeah, difficult to decide. But basically, I'd say that like MySQL, you could use MongoDB pretty much anywhere.
Okay, and the last question, I hope this makes sense, and if it doesn't, Stefan, we can address this later in a follow-up blog post. What kind of HA solution does configuration servers use to support redundancy and replication for sharding administration?
So I'm not sure I've understood the question correctly, but if it's about the config servers that are used in a sharded cluster, the config servers are highly available. So in a production environment, you will need 3 servers to make sure that at least one is available. Because the thing is that if the config servers are not available in your sharded cluster, you won't be able to change the sharding configuration, right? Because the config server are the place where this information is stored. So the sharded cluster can still operate because the MongoS instances cache the data from the config servers. So all the reads and writes that so all the reads can be served, all the writes that don't need to trigger rebalancing the data chunks will work. But well, you ultimately you will need your config servers, and the config servers are intended to be highly available because there are three of them. I hope that answers the question.
Thank you so very much. Okay, well that brings us to the top of the hour. Stefan, thank you so much for today's webinar. And audience, thank you for attending. I hope that you have a great evening, morning, afternoon, wherever you're calling in from, and we hope to see you on future webinars. Thank you again, Stefan.